I'm going to talk about roots involving fractions and decimals. Now, I'll assume that you know the basics of roots. If you don't, I would invite you to watch my introductory video. All right? So recall that when we find the square root of a number, such as 9/16, we are looking for another number that when we square that other number, we get the number that we started out with. In other words, the number that's underneath the radical. So the square root of 9/16 is equal to 3/4. Why? Well, if you square 3/4, you will get what we started with, the number that was underneath the radical. Okay? What about if we took the square root of 0.16? So that's equal to 0.4. Again, because if you square 0.4, you will arrive at the number that you started with. So 0.4 squared is equal to 0.16 if you do the decimal multiplication. All right. Now, all of this is to say that we're doing the exact same thing we would do if we were taking the square root of 25 or 36 or 81, right? We're just finding a number that when we square it, we arrive at the number we started with, okay? So can you see that the rules, the method of solution doesn't change just because we have a fraction or a decimal? All right, it's still the same procedure. So, having said that we're just doing the same thing we did when we took roots of positive integers, would you please try to find the square root of 1.44? So pause the video and try that if you like. Okay, I'll go ahead and give the answer. So by trial and error, you can eventually hopefully see that 1.2 squared is equal to 1.44. Okay? Now, what about the square root of 100/900? Pause the video and try to work that one out, please. All right, I'll go ahead and work it out as well. So by trial and error, you can hopefully see that 10/30 works. And then you can reduce that to get 1/3 for the final answer, as nice as we could make it. Now, I reduced after I found my answer. What about if I reduced first, before I did anything else? Okay, if you do, you'll still get the same answer. Watch. 100/900 is equal to 1/9. Now, if I try to find the square root of 1/9, I will eventually hopefully see that the answer is 1/3. Okay, so my suggestion would be to reduce immediately, as soon as possible. Now, the root of every number doesn't have a nice simple answer, okay, or a nice fraction or a nice decimal with just a few digits. Let me show you an example of what I'm talking about. Try to find the square root of 2. You could spend all day trying different decimals and you will never, let me repeat that, you will never arrive at a decimal with a finite number of digits that is equal to the square root of 2. Okay? The best you could do is get close to the square root of 2 with a decimal containing a finite number of digits. All right? Why don't you, with a calculator or with pencil and paper, why don't you try to find 1.4 squared? If you square 1.4, you will see that it is close to 2, but it's not exactly equal to 2. Now, by trial and error, you can get better and better approximations, but you'll never have no error in your approximation. Okay, an even better approximation would be 1.41421. Square that decimal, and you'll see that that's even closer to 2, but again, it's not exactly equal to 2. Okay? Another decimal that has this issue is the square root of 3. Now, that's approximately 1.7, and you can square 1.7 to see that that's close to 3, but not exactly equal to 3. And then again, you could try to get a more accurate answer, but you'll never get a finite decimal that's exactly equal to the square root of 3. Okay? If you tried, I'll just tell you what you would end up with. You might get 1.3205, and then maybe you want to stop there. Okay? Square that if you like, and you'll see that the square of that last decimal is even closer to 3. All right? So let's try an example that let's try approximating a square root that doesn't have a finite decimal for the exact answer. So would you please try to find the square root? Now, let me be careful the way I word this. Would you please try to find an approximation for the square root of 7 by trial and error without using a calculator? Okay? So do that for a few minutes now if you like. All right, so I'll go ahead and tell you an approximation that might be adequate for lots of purposes. 2.6. Okay, maybe you found a more accurate answer. If you did, that's great, but 2.6 is on the right track. All right.